In the previous lectures, we learned three building blocks: the unit impulse delta of t, the unit step u of t, and the unit ramp r of t. Today we'll practice writing composite signals as combinations of these functions. The key idea is, any piecewise linear signal can be built by adding shifted and scaled copies of delta, u, and r. Let's start with simple combinations. First, delta of t plus 1 plus delta of t minus 3. This creates two impulse arrows, one at t equals -1 and another at t equals 3. Next, u of t minus u of t minus 4. The first step turns on at t equals 0 and the second turns off at t equals 4. The result is a rectangular pulse of width 4 and height 1. Now a staircase function, u of t minus 2 plus u of t minus 4 plus u of t minus 6. Each shifted step adds one more level. At t equals 2, the first step turns on, giving level 1. At t equals 4, the second step adds another one, reaching level 2. At t equals 6, the third step brings us to level 3. The result is a perfect staircase. For ramp combinations, we'll use a powerful technique called slope analysis. The idea is simple. At each breakpoint, add up the slopes of all active ramp components. If the total slope is +1, the signal rises. If it drops to 0, the signal stays flat. If it goes negative, the signal falls. This method works for any combination of shifted ramps. Let's apply slope analysis to r of t minus r of t minus 3. Before t equals 0, nothing is active, so the slope is 0. At t equals 0, r of t turns on with slope +1, so the signal rises linearly. At t equals 3, the second ramp subtracts slope 1, making the total slope 0. The signal levels off at a value of 3. The result is a flat top ramp. It rises from 0 to 3, then stays constant. Our final example: r of t minus 2, r of t minus 2 plus r of t minus 4. Before t equals 0, the slope is 0. At t equals 0, the first ramp starts with slope +1. At t equals 2, the second term subtracts slope 2, making the net slope -1. The signal starts decreasing. At t equals 4, the third ramp adds slope +1, making the net slope 0. But the value has already returned to 0. The result is a symmetric triangle, rising from 0 to a peak of 2 at t equals 2, then falling back to 0 at t equals 4. To summarize, we practiced writing composite signals from building blocks. Shifted impulses create spikes. Shifted steps create pulses and staircases, and shifted ramps create linear segments. The slope analysis technique is key for ramp combinations. List the slopes at each breakpoint, and the shape reveals itself. In the next lesson, we'll explore signal derivatives and how discontinuities produce impulses.